Welcome back. This is lesson 10A, where we are going to calculate limiting reagents by using the examples in the textbook. I'm on the second example and I call this lesson 10B. So on page 206 you've got a portion of sulfur dioxide released into the air is converted to sulfuric acid according to the reactions given below. If 5 moles of sulfur dioxide, 2 moles of oxygen and an unlimited amount of water react, which substance is the limiting reagent? Obviously it won't be the amount of water, so we need to look at this reaction A. So 2 moles of sulfur dioxide needs 1 mole of oxygen. So we started off with 5 moles of SO2 and that needs 2.5 mole of oxygen. So we have too little oxygen if we started off with only 2 moles of oxygen. So the answer to question 2.1 is oxygen is the limiting reagent. This is what will be used up during the reaction. So this is what we will need to use in the next calculation. The moles of oxygen. We start off with 2 moles of oxygen and I'm using the mole ratio in the balanced equation. 2 moles of oxygen will gives 4 moles of sulfur trioxide. Now I need to move over to reaction B. We've got 4 moles of sulfur trioxide and that would give 4 moles of sulfuric acid. And the question asked for the mass of sulfuric acid. So it's the moles times the molar mass. And if I'm not mistaken, the molar mass of sulfuric acid is 98 grams per mole. So it's 4 times 98. I could be wrong here. 4 times 98 is 392 grams. So it's 2 for hydrogen. I'm just checking myself on the molar mass, plus 32 for sulfur, plus 64 for the 4 oxygens. I was right. Good. Next one. Example 3 is on page 206 to 7. They say if 50 cubic centimeters of silver nitrate solution with a concentration of 0.2 mole per cubic decimeter is added to 100 cubic centimeters of sodium chloride solution with a concentration of 0.5 mole per cubic decimeter, a white precipitate forms. So firstly we need to write a balanced equation for this reaction. Silver nitrate plus sodium chloride will form silver chloride and sodium nitrate. It's an ion exchange reaction during which a precipitate is formed. So here you need to know your solubility rules, and it's the silver chloride that will form the precipitate. We can indicate it with an S or an arrow going down. 3.2, it's AgCl or silver chloride. Both were required. 3.3, how many moles of reactants are present initially? So initially we start off with a 50 cubic centimeter with a concentration of 0.2 mole per cubic decimeter. So this volume must be changed to cubic decimeter, 0.05. You have to divide by 1,000. Concentration is that. So concentration is mole divided by volume. So the moles would be 0.2 times 0.05, which is 0.2 times 0.05, which is 0.01 mole. And the sodium chloride, you started off with 100 cubic centimeters, so the volume of sodium chloride is 0.1. You divide 100 cubic decimeter, and the moles would be concentration times volume, so it is 0.5 times 0.1. 0.5 times 0.1 is 0.05 mole of sodium chloride, and that one was the silver nitrate. So we've done question 3.3, question 3.4, which one is the limiting reagent? So the ratio is 1 to 1. So for 3.4, I have silver nitrate as the limiting reagent. Right, so that will be used up. Calculate the mass of precipitate formed. So I am going to do that calculation here. 3.5. 1 mole silver chloride, silver nitrate gives 1 mole silver chloride. So if I have 0,01 mole of the silver nitrate, the mole of silver chloride will be 0,01 mole. So the mass is the moles times the molar mass. So it's 0.01, and the molar mass for silver chloride is the 35.5 plus 200 and something. To 108 plus 108, 108, that's 140, 143.5, 143.5, so the mass times 0.01 is 1.435 grams. Right, that brings us to the end of this lesson. Thank you for joining.